Hello and welcome to Sleepy Science Story. This is your time to slow down, to let the world outside gently quiet itself while your thoughts drift like dandelion seeds on a soft breeze. Tonight, we're going to tiptoe beneath the surface of the Earth and explore what really happens during an earthquake. We'll move gently through shifting plates, rippling waves, and the silent power that hums beneath our feet. I do hope this story isn't so interesting it keeps you awake, but if it does, at least your dreams will be filled with warm, wobbly wonders. Before we begin, I'd love it if you gave this video a gentle like and tapped the subscribe button softly, of course. And if you feel like sharing, let me know in the comments where in the world you're listening from tonight. Is the ground beneath you still and sleepy, or is it whispering secrets only the Earth can hear? Let's begin where the world often ends, at the surface. Roads and rooftops, trees and sidewalks, all resting on what we casually call solid ground. It feels dependable, steady, a foundation for everything. But the truth, whispered gently beneath the stillness, is that the ground is not as still as it seems. Beneath our beds, our bookshelves, our quiet coffee cups, the Earth is always moving, not with haste, but with patience. A slow, almost imperceptible drift that continues day and night whether we notice or not. The crust beneath us is not one single piece, but many. Vast slabs of rock called tectonic plates, sliding slowly across the Earth's surface as if they are floating on a warm, thick soup of softer rock below. You don't feel them move because they do it with the delicacy of fingernails growing or clouds rolling across the sky. But move they do. And in their long, slow journeys, they press against each other, pull apart, or slide sideways. Sometimes they get along just fine, shifting past each other without much fuss. But other times, they don't. They press and stick, and resist. And as they do, tension builds quietly in the dark. Imagine two massive blocks of stone, each the size of continents, trying to pass each other in a crowded hallway. They lean in, they brace, and for a long while they don't move at all. But beneath that quiet standstill, energy gathers. The longer they hold, the more they store. Until one day, when they can't hold any longer, something gives. It doesn't start with a crack or a roar. It starts with a slip, a small movement deep underground where no one can see. This slip sends a ripple outward, and that ripple becomes a wave. The wave travels through the Earth itself, radiating like a ring in a pond, spreading far beyond the point where it began. And then, if you're close enough, you feel it. Maybe just a gentle sway at first, a curious rattling of glasses, a creak in the ceiling, or maybe more. Maybe the ground rolls beneath your feet like the deck of a ship in rising waves. The world shifts in ways that feel strange to our bodies, tuned as they are to expect stillness. And yet this movement is natural. The Earth isn't malfunctioning. It's breathing, resetting, releasing what it could no longer hold. Even when it feels sudden, even when it wakes us from dreams or catches us in quiet moments, an earthquake is not a surprise to the planet. It is the end of a sentence it has been writing for years. A sigh let out after a long pause. A story told not in words, but in motion. So the next time the ground beneath you seems calm and unmoving, remember this. You are resting on something ancient and alive. Something that shifts slowly, patiently, and every now and then gives itself a little shake just to keep the rhythm of the world in time. It's easy to think of the Earth as a solid thing, like a giant rock holding everything in place. But if we look closer, or rather if we imagine smaller and deeper, we begin to see that the planet is not so much a finished sculpture as it is a slow, swirling process. The surface that we stand on, the ground we call home, is only the outermost layer of something far more complex. The Earth's crust is surprisingly thin when you consider the scale of the planet. Compared to the vast bulk of the Earth below it, the crust is like the skin on a cooled pudding or the surface of a frozen pond. It seems strong, and for the most part it is, but it floats on something much softer. Beneath the crust lies the mantle, a slow-churning sea of rock that isn't liquid in the way water is, but isn't rigid either. It moves, very slowly, over long stretches of time. The mantle flows the way glass flows in old windows, or glaciers flow across valleys. It is thick, heavy, and always in motion, warmed from below by the heat left over from Earth's formation, and by the decay of radioactive elements that still hum softly in the deep. This slow flow is what sets the plates in motion. The crust is broken into pieces, some larger than entire continents, and these plates ride on top of the mantle's movements like rafts drifting on an unseen current. They move at speeds that are both impressive and absurdly slow, usually just a few centimeters a year. That might not sound like much, but over the course of a human lifetime, those small shifts can add up to many meters. Over geologic time, they redraw coastlines, raise mountains, and crack open ocean basins. The surface of the planet is a patchwork, and the seams where the pieces meet are rarely quiet. Some plates pull away from each other, and when they do, new crust is formed from molten rock that wells up from below. Other plates push together, and when that happens, one plate might dive beneath the other, sliding down into the mantle where it melts once again into the deeper earth. And then there are places where plates slide past each other, locked together in a slow, silent standoff. These are the places where earthquakes tend to happen. The boundaries between plates are not peaceful borders. They are zones of tension, of friction, of potential. So when we say the ground is moving, it's not just a poetic idea. It is literally true. The continents are not fixed in place. They float, they drift, they collide and separate like sleepy dancers circling the ballroom floor. We don't notice it from day to day, and we don't need to. But every now and then, the Earth reminds us that it is not a static world. It is restless, layered, and quietly alive. And as we sleep, as we walk, as we go about our days, it continues to turn, to stretch, and to slide beneath us. Imagine the entire surface of the planet as a great jigsaw puzzle, but instead of being made from cardboard pieces on a table, it is made from immense slabs of stone the size of continents. These slabs are the tectonic plates, and they are not fixed in place. They are enormous, heavy, and yet always moving, floating on the slow, thick currents of the mantle below. For most of us, these movements are invisible, too gradual to notice. But over centuries they shift whole oceans and mountain ranges, shaping the face of the Earth in ways we only see when we compare maps across deep time. These plates drift at a speed similar to the growth of your fingernails. It is a strange image, but a true one. Something so vast, moving so quietly, that only the planet itself can feel it. And like all slow movements, they carry with them a hidden patience and a hidden tension. Sometimes these plates meet and push against one another, other times they pull apart. And sometimes they slide past each other in opposite directions. Each of these motions creates its own kind of strain. Along the edges where plates collide or scrape, the rock becomes locked, pressed together with incredible force. For years or centuries, nothing appears to happen. On the surface, everything seems still. Cities rise, forests grow, people go about their lives unaware of the quiet pressure gathering beneath their feet. But deep down, the plates are holding on, resisting their own motion, building up energy like a bowstring being drawn back. When at last the strain becomes too great, the rock gives way. In an instant, the locked sections slip, and the built-up energy is released as an earthquake. Thinking of tectonic plates as sleepwalkers helps soften their immensity. They are like enormous beings shuffling past each other in the dark, barely aware of their own size, sometimes brushing shoulders, sometimes tripping. When they stumble, we feel it. Not as a gentle nudge, but as a ripple of motion through the ground, a reminder that we are living on a planet that is not fixed but fluid, a place that is always, in some quiet way, becoming. Without these slow drifts and sudden slips, there would be no high mountains or deep ocean trenches. The Earth's surface would wear flat, a dull and lifeless crust. It is the movement of these plates, the patient wandering and occasional shudder, that keeps the surface renewing itself. So when we talk about earthquakes, we are not just talking about a single event. We are talking about a moment in a much longer dance. Tectonic plates glide and collide for millions of years, and every now and then, their invisible struggle writes a moment of motion across the surface. We feel it as a jolt, but to the Earth it is only a sigh, a small adjustment in an endless journey. It is a strange thought that the ground beneath us, which feels so quiet and firm, can hold tension the way a muscle does. Beneath the sidewalks and forests and oceans, the Earth is often holding its breath. At the edges where tectonic plates press against one another, movement does not always come easily. The plates do not slide freely. They push and press, locking together in rough contact, each trying to move in its own direction but unable to get past the other. In that grip, a slow and silent energy begins to build. It is not sudden. It is not loud. It is the kind of build-up that takes years, decades, even centuries. But it happens just the same, without our noticing. The crust bends very slightly under the strain, changing shape so subtly that no human could ever feel it. Imagine a wooden floorboard slowly warping as it holds more weight than it was meant to bear. At first, there is no sound. Then maybe a faint groan. Eventually, without warning, it snaps, not because of one final load, but because of the many small forces that built up over time. Earthquakes work in a similar way. The energy stored in the rocks around a fault line is like that pressure in the floorboard, and when the strength of the rock is finally exceeded, it breaks. The stored energy is released in an instant, traveling outward through the ground as seismic waves. But until that moment comes, the strain remains invisible. We walk across landscapes that are, quite literally, under stress. A gentle valley may be sitting above a locked fault, its surface slowly bending over the decades as tension accumulates. A calm coastline might be hovering on the edge of motion, each year storing a little more energy than the last. In some places, scientists use satellites and GPS markers to detect these slow changes. A hillside might be shifting by a few millimeters a year, or a stretch of coastline might be quietly rising or falling. The land changes shape so slowly that only machines can see it, but the clues are there if we know how to look. And when that energy is finally released, it does not spread evenly. Some of it becomes motion, the shaking we feel on the surface. Some becomes heat, friction burning through stone as one side of the fault grinds past the other. Some of it is used to break rock, to open new fractures, to rearrange the underground landscape. The earth changes shape, and for a brief moment, the tension vanishes. The pressure that had built up so quietly for so long is gone, released in seconds, but it is never the end. Over time, the plates continue to move. The fault that slipped today may stick again tomorrow. The process begins again, slowly and invisibly. As the stress returns, the ground does not forget what it was doing. It continues to shift. It continues to hold. and somewhere deep below another silent pressure begins to grow. There is something oddly poetic about the way an earthquake begins. After years of stillness, after decades of quiet tension held deep within the earth, the whole thing starts with something so simple it almost feels accidental. A slip, that is all it takes. A single sudden movement along a fault, like the tug of a stubborn drawer finally giving way. In that small moment, something ancient and powerful is released. The rocks on either side of the fault, once stuck tight by friction, finally slide past one another. Sometimes they shift just a few centimeters, sometimes several meters. But even a small movement, if it happens quickly enough, can send energy pulsing through the planet in waves we feel at the surface. The place where this initial slip happens is called the focus. It usually sits deep below the ground, sometimes many kilometers beneath the surface. This is where the earthquake is truly born. Above that point, directly overhead, is the epicenter. It is the location we often hear about, the place where the shaking feels strongest, though not always the place of greatest damage. The waves that travel out from the focus move in all directions. Some travel down into the deeper layers of the earth, where they may bounce and bend through molten rock. Others travel upward and outward, racing toward the surface with a kind of invisible urgency. And when they arrive, the world above begins to move. It is strange to think of the ground, so heavy and solid, behaving like water, but that is exactly what it does. The seismic waves pass through rock in much the same way ripples move across a pond. The ground rolls, it shudders, it shakes. Sometimes the motion is gentle, like being rocked in a cradle. Sometimes it is sharp and jarring, like a sudden drop in a dream. It all depends on the size of the slip, the distance to the focus, the kind of rock the waves must travel through. No two earthquakes are ever exactly the same. And in the moments just after that slip, something else happens too. The earth speaks, not in words, but in movement. A dog may lift its head, a lamp may begin to sway. A person may feel their balance shift, as if the ground has turned briefly into the deck of a boat. In cities, buildings may groan and sway, designed to bend rather than break. In the countryside, trees may rustle without wind, and streams may ripple without a breeze. The planet is not angry, it is not broken. It is simply in motion, responding to a shift that has been waiting for years to arrive. Then, often as suddenly as it began, the first shaking fades. Not all at once, but gradually, like the final echoes of a bell, the energy has moved on. But in its wake, the ground is changed. What was once held tight has now let go. The earth has rearranged itself, and the memory of that first slip lingers quietly in the soil. After the slip, after the sudden release of tension deep beneath the earth, something remarkable begins to unfold. That moment of motion, though it may have happened kilometers underground, sends ripples through the planet itself, not ripples in water, but in stone. Waves of energy radiate outward in all directions, passing through rock as easily as sound travels through air. These waves are called seismic waves, and they are what we feel when the ground begins to tremble. But more than that, they are the Earth's way of passing along the message that something has changed, that somewhere a shift has taken place. It is strange to imagine that rock can behave like something soft. We think of stone as solid, unyielding, incapable of movement unless it crumbles. But during an earthquake, rock behaves almost like jelly. It flexes, it vibrates, it carries the pulse of the earth across vast distances. The energy released during a quake travels faster than a speeding train, and yet its motion can feel gentle or violent depending on many things. The type of rock it passes through, the direction of the waves, the distance from the source, the hidden shape of the fault itself. There are different kinds of seismic waves. Some move deep through the body of the Earth. These are the primary and secondary waves, often called P waves and S waves. The P waves arrive first. They compress and stretch the ground, much like a slinky toy being pushed and pulled. They are fast but not always the most noticeable. Then come the S waves, which shake the ground side to side. These waves move slower but tend to cause more of the movement that people feel. After them, surface waves arrive, rolling along the crust like ripples across a pond. These surface waves can be the most dramatic of all. They make the ground roll and sway. They can lift and drop, twist and slide, making buildings shiver and roads ripple like fabric. Each wave carries with it the memory of the fault's movement, not in pictures or sounds, but in motion. It is as though the Earth is echoing what happened deep below, translating that event into something felt across hills, valleys, and cities. The waves do not last long, usually just a few seconds or minutes. But in that time, they can travel hundreds of kilometers. They may wake a person from sleep, knock a book from a shelf, or tilt a picture frame just slightly. They can also be silent to the senses, recorded only by instruments. Like whispers, the ground tells only to those who know how to listen. Once the waves pass, the ground grows still again. But it is not the same stillness as before. Something beneath has changed. The fault has moved. The energy has gone. And all that remains on the surface is the soft reminder that even the most solid ground can carry a ripple when the passer, Earth, decides to speak. If you could somehow ride along with an earthquake, moving with the waves that ripple through the ground, you would find yourself on a strange and invisible journey. These waves, called seismic waves, come in different forms, each with its own shape, its own motion, and its own rhythm. They are not all the same, and the way they travel through the Earth reveals secrets about the planet's structure and the nature of the earthquake itself. Some waves move fast and quiet, barely noticeable except to the most sensitive instruments. Others arrive like a soft roll beneath your feet, and some come with a jolt, like the Earth itself has given a single strong shrug. The first to arrive are usually the primary waves, known simply as P waves. These are compressional waves, which means they move the ground back and forth in the same direction the wave is traveling. Imagine squeezing and stretching a spring. The motion is subtle and quick, more like a thump than a shake. These waves move through both solid rock and liquid layers, which makes them useful for scientists studying the deep interior of the planet. But to the average person, a P wave might feel like a distant rumble or a strange, unsettling pressure in the ground. After the P waves come the secondary waves, or S waves. These move the ground side to side or up and down, depending on their direction. They cannot travel through liquids, only solids, which helps seismologists map where Earth's solid and molten layers begin and end. S waves often cause more noticeable motion, the kind that makes furniture shift and buildings sway. The shaking can feel like the floor is sliding or bouncing beneath you, even though nothing is visibly moving yet. It is an eerie sensation, as if the ground has forgotten how to be still. Then come the surface waves, which are often the slowest to arrive but the most dramatic to experience. They travel along the outer layer of the Earth, and their motion can roll the ground like ocean waves or shake it in large, looping patterns. These are the waves that make roads ripple like water and cause tall buildings to sway back and forth. They tend to linger longer and carry more energy across wide areas, especially in softer ground. Sometimes people describe the sensation as dizzying, as if the entire world has briefly become liquid beneath their feet. Each type of wave moves at a different speed and in a different direction. They twist and bend through layers of rock, bouncing off hard boundaries and refracting through soft zones. The shape and speed of these waves help scientists figure out where the earthquake started and how strong it was. To seismologists, these waves are not just disturbances. They are signatures, each carrying a piece of the story written by the fault that slipped. And though most of us cannot see them, the Earth feels them fully. With each passing wave, it echoes a reminder that motion, even when unseen, is a language the planet has always spoken. When seismic waves reach the surface, they arrive not as silent travelers, but as sudden visitors that reshape the moment. The ground, which has always seemed firm and loyal, begins to move. Sometimes the motion is subtle, like a gentle rocking that makes ceiling lamps sway and water ripple in glasses. Other times, the movement is quick and startling, with the floor shifting beneath your feet and the air seeming to hum with vibration. In cities, this can feel especially surreal. Buildings designed to stand tall and strong begin to sway gently back and forth, built not to resist motion entirely, but to move with it in order to stay standing. The experience of an earthquake is not always loud. Often, the first sensation is confusion, a sudden imbalance, as though your own body has forgotten how to stand properly. You might hear creaks from the walls, the distant rattle of dishes, or the low groan of beams adjusting to stress. In a quiet room, even a small earthquake can sound like the house is sighing. The air may feel strangely still, as if everything is pausing to listen. Outside, trees might tremble without wind. Leaves flutter, windows tap in their frames, and sometimes a car alarm may give a confused cry, unsure of what has disturbed it. In the countryside, the experience is different. The open land responds in its own quiet way. Fences may sway, birds might take off in nervous flocks, and animals become alert. Horses stamp, dogs bark, even the insects seem to hush. A still lake may ripple without warning, not from anything touching the water, but from the earth itself moving beneath it. Far from cities and roads, the shaking might be the only sound in the world, a soft rumble rolling through hills and pastures, like a passing train that no one sees. The intensity of shaking depends on many things. How close you are to the fault, what kind of rock or soil lies beneath you, whether you are in a valley or on a hilltop. In some places, the quake might feel like a small tremor, barely enough to notice. In others, it might seem as though the whole world has tilted sideways. It is not just what the earth is doing, but how the ground chooses to carry the message that matters. Some soils amplify motion, making the shaking feel stronger. Some rocks absorb the waves gently, softening the impact like a thick blanket. No matter how it feels, one thing remains the same. Earthquakes do not knock politely. They arrive suddenly, without invitation, reminding us that the earth is alive beneath our feet. After the shaking stops, the world feels quiet in a different way. As if the air itself has exhaled, the stillness returns, but now it carries a memory, a trace of motion that lingers long after the waves have passed. And even if everything looks the same, the earth knows something has shifted. It always remembers. Beneath every earthquake is a starting point, quiet and hidden, where it all begins. This place is called the focus, or sometimes the hypocenter, and it sits deep underground where no one can see it. It is the point where the fault first slipped, where the tension that built up over years finally gave way. This is where the earth made its first move, silently and invisibly. It does not always happen at great depth. Some quakes begin just a few kilometers below the surface, while others originate far deeper, tucked away in the darkness where only pressure and heat exist. Directly above the focus, on the surface of the Earth, lies the epicenter. This is the name often mentioned in the news. It marks the spot on the map where the earthquake seems to come from, the place closest to where the rupture started. But the epicenter is not always the most affected. Earthquakes do not follow rules of fairness. The shaking might be stronger in a nearby valley, or worse in a soft patch of soil many kilometers away. What matters is how the energy moves and how the ground responds to it. The focus is not a single spot, frozen in place. During larger earthquakes, the rupture may spread along the fault for many kilometers. It begins at the focus, then unzips the rock in one direction or both, like a tear in fabric opening wider and wider. The shaking we feel at the surface reflects not just that first moment of movement, but the entire path the fault takes as it slips. A quake that lasts 10 seconds is often one that traveled quickly along a fault line, spreading its energy as it went. Though the epicenter gives us a convenient location to point to, it is just the tip of a deeper story. Most of what happens during an earthquake stays hidden beneath the surface. The rupture slices through rock, creating new fractures, shifting ancient boundaries and stirring layers of earth that have not moved for centuries. These changes are invisible to the eye, yet they shape the way the land will respond to the next quake, and the next one after that. Instruments help us find these points. Though we can never see them directly, seismographs placed around the world record the arrival times of different seismic waves. By comparing how quickly the waves reached each station, scientists can trace them backward, like echoes to their source. The deeper the focus, the more muted the shaking tends to be at the surface. Shallow earthquakes often feel stronger because the energy has less distance to travel before it reaches us. So next time you hear about an epicenter, imagine not just a dot on a map, but a point above a much deeper change. Imagine the first slip, hidden miles beneath your feet, and the quiet journey the energy took as it rose to the surface. The ground may have stopped shaking, but somewhere down below, the Earth remembers exactly where it all began. After the main earthquake has passed, and the waves have rolled through the ground and faded into memory, many people believe the shaking is over. But often, the Earth has a few more quiet things to say. These later tremors are called aftershocks. They are smaller earthquakes that follow the main event, sometimes within minutes, sometimes hours, sometimes days or weeks later. They are like echoes in stone, repeating the story of the original quake but with less strength, like a sigh after a shout. Aftershocks happen because the Earth is still adjusting. The main earthquake may have relieved the built-up pressure along one part of a fault, but it can also shift stress to nearby areas. These neighboring sections of the fault, already holding their own quiet tensions, can suddenly become unstable. One slip leads to another. And while the first earthquake is often the strongest, these follow-up movements can still be powerful in their own right. Sometimes, aftershocks feel like small twitches in the ground, barely there. A light rumble that makes you glance up from your tea or pause in the middle of a thought. Other times, they are sharp enough to rattle furniture or cause more damage. Especially if buildings were already weakened by the first quake, their unpredictability can make them feel unsettling. Just when you think everything is quiet again, the ground gives one more little tremble. There is no exact number of aftershocks that follow a major earthquake. Some sequences have only a few, others include hundreds or even thousands, especially in the case of very large earthquakes. They usually become weaker and less frequent over time. Scientists describe this decay in activity with simple patterns. The bigger the main quake, the more aftershocks it tends to have. And most aftershocks happen within a few weeks of the main shock, though in some cases they can continue for months. People sometimes wonder if an aftershock could be stronger than the original quake. By definition, it cannot. If a larger quake follows, The first one is reclassified as a foreshock, and the second becomes the main event. This can happen, though it is rare. Earthquakes do not always follow neat patterns. They are part of a shifting, living system that we are still learning to understand. Aftershocks also have a psychological effect. They can bring back the tension of the original quake, especially in places where the first shock caused damage or fear. Each small jolt becomes a question: is this the end or the start of something new? But usually, they are simply the Earth settling into its new shape, like a body stretching after waking up. The crust is finding its balance again, adjusting the pressure, fitting the broken pieces back together in a new arrangement. Even when the rumbling stops for good, the memory lingers. People listen more closely. They watch the ground with quieter eyes. They remember that the Earth does not always sleep in silence. Sometimes it stirs in whispers before it rests again. To most of us, earthquakes are something we feel. A sudden sway, a trembling floor, a moment when stillness is replaced by motion. But to scientists who study the Earth, earthquakes are also something they can hear, even when no human feels a thing. The instruments they use are called seismometers, and they are like stethoscopes for the planet. They listen to the smallest murmurs of the Earth and record the movement of ground that may shift by only the width of a human hair. These devices sit quietly in the soil or in small huts on lonely hillsides, always waiting, always listening. A seismometer works by holding a weight perfectly still while the ground moves around it. As the Earth shakes, the base of the instrument moves, but the weight remains in place due to inertia. This difference in motion is recorded on paper or, more often now, through digital signals. The result is a seismogram, a delicate pattern of lines that show the shaking of the Earth over time. Each spike, each curve, tells a part of the story. How fast the ground moved, how long the shaking lasted, how strong the waves were. Even when no earthquake is happening, the seismometer keeps recording. It picks up the hum of ocean waves crashing on distant shores. It hears the rumble of heavy trucks passing miles away. It catches the faintest tremors from other parts of the world, energy traveling through the deep layers of the planet. The Earth is never truly silent, and the seismometer proves this. There is always a low whisper in the rocks, a background noise of movement too soft for us to notice. When a quake happens nearby, the seismometer springs to life. The first wave to arrive is usually the P wave, and it appears as a small twitch in the line. Then comes the S wave, more pronounced and sudden. Finally, the slower surface waves arrive, often creating the tallest peaks on the graph. By comparing seismograms from different locations, scientists can figure out where the earthquake began. It is a bit like triangulating the position of a sound by noticing when it reaches different microphones. Over time, entire networks of seismometers have been placed. Across the globe, some sit on land, others rest on the ocean floor. Together, they form a web that watches over the shifting plates and listens for every whisper of motion. They do not prevent earthquakes, but they help us understand them. They reveal which faults are most active, how energy moves through different kinds of rock, and where the stress may be building next. In this way, a seismometer becomes more than just a tool. It is a companion to the Earth's secret language. It writes down what the ground says in moments of silence and in moments of surprise. And in the quiet hours after the shaking ends, the seismograph line softens once more, returning to stillness, like the Earth itself has taken a long, deep breath and settled into sleep. When people hear about an earthquake, one of the first things they want to know is how strong it was. Was it big? Was it small? Did it make the ground shake like a breeze or like thunder? To answer this, scientists often refer to a number, a simple figure that tries to capture the size of something so complex. That number usually comes from a scale called the Richter scale. Though the method behind it has changed over the years, the idea remains the same. It is a way of turning ground motion into a measurement, something you can write on paper, something you can compare from one quake to another. The Richter scale was developed in the 1930 seconds by Charles Richter, a seismologist who wanted a better way to describe earthquakes in California. At the time, most people just used words. They would say an earthquake was mild or strong or terrible. But Richter wanted a number that came from the ground itself, not just from the experience of people. So he created a scale based on the amplitude of waves recorded by a seismograph. The bigger the waves, the bigger the number. But numbers can be tricky. The Richter scale is logarithmic, which means each whole number increase represents a tenfold increase in wave size. A magnitude, 6, is not just a little bigger than a 5, it is 10 times stronger in terms of shaking, and it releases more than 30 times as much energy. A magnitude 7 is 100 times stronger than a 5. This makes it easier to understand why small earthquakes can be felt without causing damage, while larger ones can reshape landscapes and cities. Over time, scientists realized that the Richter scale, while helpful, was not perfect. It worked best for small local quakes but became less accurate for very large or distant ones. Today, they often use a different method called moment magnitude. This scale considers not just the wave size, but also the area of the fault that slipped, the amount of movement, and the kind of rock involved. It gives a clearer picture of the total energy released, even though the numbers it produces are usually close to those from the Richter scale. When you hear about a magnitude 6.8 or a 5.3, it often comes from this newer method. Still, most people think of it as the Richter scale, because the name has become part of how we talk about earthquakes. It is simple, familiar, and easy to understand, even if the Earth itself does not care about numbers. The planet shifts, slips, and shakes with no concern for how we measure it. But we measure anyway, trying to bring meaning to the motion. In the end, a number is just a way of saying something happened. It tells us the shaking was small or large, but it cannot capture the full feeling. The surprise, the awe, the way the air seems to pause while the ground moves beneath you. That part stays beyond the numbers. That part belongs to the Earth. In some places, after an earthquake, the land looks exactly the same. A bit of dust, a few swaying branches, maybe a crack in a wall. But in other places, the world changes in ways that are not so subtle. The shape of the land itself can be altered. Hills rise where the ground was once flat. Riverbeds shift their paths without asking permission. Roads buckle, fences no longer line up, and once familiar corners of the landscape seem to tilt or stretch ever so slightly. It does not always take a massive quake to leave a mark. Sometimes the Earth moves just enough to rewrite its own surface. There have been earthquakes where entire coastlines lifted by several meters in just a few seconds. What took millions of years to shape can be adjusted in a blink. It is as if the Earth suddenly remembered an old design and decided to return to it. In some valleys, the land splits open, leaving long, narrow cracks that run for miles, like wrinkles pressed into a tablecloth. In other places, landslides come tumbling down, especially when rain has made the soil soft and heavy. Forests tilt, boulders roll, and the ground at the bottom of a slope is suddenly covered in the memory of the hill above. Earthquakes can even cause new lakes to form. When the land shifts enough to block a river, water begins to gather behind the new barrier, pooling slowly until it finds a new path or settles into a quiet basin. This has happened more than once, leaving behind lakes that seem peaceful today but were born out of sudden change. In cities, the changes may not look natural, but they are no less dramatic. Pavement bends and breaks. Buildings settle at strange angles. Entire blocks can look as if someone picked them up, gave them a gentle shake, and then set them back down just slightly out of place. Not all changes are destructive. Sometimes, after a quake, scientists discover ancient faults they never knew existed. A sudden crack in the ground can reveal the deep history of an area, layers of rock folded and torn over countless millennia. These are stories the Earth has carried quietly, and it takes a bit of movement for them to be told. Even a small earthquake can bring clues to the surface, evidence of older quakes written in the scars of stone. Over time, many of these changes soften, rain smooths the cracks, plants grow over the scars, roads are repaired, buildings rebuilt, but the land remembers. The lines on a satellite image might show a faint trace of the rupture years later. A farmer might still notice that a fence no longer follows the same straight path. And deep below, the fault that shifted continues its quiet existence, waiting. The surface may appear calm again, but it has been altered, gently or greatly, by the quiet force of a planet always in motion. Most earthquakes happen on land, where we feel the shaking through our feet and see the motion ripple through buildings and trees. But many of the strongest earthquakes happen beneath the ocean, deep under the surface where the crust hides its tension beneath miles of water. When these underwater faults slip, the shaking may be invisible to those on land, but the results can travel farther and faster than almost any land-based event. If the movement beneath the sea is strong enough, it can lift or lower large sections of the ocean floor, and when the seafloor rises or falls, it moves the water above it too. This sudden displacement of water creates something powerful and quiet at first. A wave begins to form, not like the crashing surf along a beach, but a long, low swell that stretches across the open ocean. Out at sea, a boat might not even notice it passing by. The wave may be only a meter high, rolling gently under the hull like any other current, but its energy is vast. Unlike wind-made waves that break quickly, this wave, born from the shifting earth, carries the full force of the seafloor's movement in its long shape and hidden strength. This kind of wave has a name. It is called a tsunami, which means harbour wave in Japanese. It is a fitting name because the most visible and dramatic effects happen not out at sea, but when the wave reaches shallow coastal waters. As the ocean floor rises near the shore, the wave begins to slow, but it does not stop. Its height increases. As the energy compresses into a smaller space, what was once a quiet ripple becomes a wall of water, tall and fast and full of motion that began hundreds or even thousands of kilometers away. When a tsunami reaches land, it does not behave like a normal wave. It does not curl and crash. Instead, it rushes in, more like a sudden flood. The sea pulls back just before it arrives, a strange and eerie sign that something is coming. The water recedes far past the usual shoreline, revealing fish and seaweed and sand that should remain hidden. People unfamiliar with this signal might wander out, curious. But the wise ones know it is time to run, because the water always returns, and when it does, it comes with force and speed that cannot be outrun. Tsunamis can carry buildings, trees, and cars in their path. They can climb up river channels, spill into towns, and pull debris back out to sea when they recede. They do not last forever, but the damage they cause can take years to repair. Even small undersea earthquakes can sometimes trigger tsunamis, especially if the movement is vertical and rapid. Still, the ocean returns to calm eventually. The waves settle, the water becomes quiet again, but hidden deep beneath the waves, the fault that moved remembers its shift. and somewhere in the vast blue stillness, the energy of the earth waits patiently for its next motion, its next soft whisper beneath the sea. The surface of the earth is filled with quiet lines. Some are rivers, some are roads, some are the edges of shadows cast by mountains, but some are deeper and older. These are faults, the fractures in the crust where two blocks of rock meet and move. They are not visible from a distance unless they have shifted recently, but they are always there, lying beneath hills, plains, and even oceans. They are not mistakes in the Earth's design. They are features, natural and necessary. If the Earth is a living planet, then faults are part of its joints, the places where it bends and stretches as it moves. Faults come in many types. Some slip side to side, some push upward, others pull apart. Each one forms as the result of pressure building over time. They mark where the crust has given into stress, where it has broken to make room for change. Once a fault exists, it does not go away. It may lie quiet for centuries, holding its shape, waiting. But under the surface, the pressure continues to build. Eventually, the fault moves again. Sometimes the movement is small, just a slight shift. Other times it is large enough to be felt hundreds of kilometers away. In a way, faults are like folded notes tucked deep within the earth. Each time they move, they reveal a little more of the story they hold. The layers of rock around them become crumpled, twisted, or stretched. Geologists read these signs like handwriting. A steep cliff might show where the land once jumped during a quake. A bend in a river may follow the invisible trace of a fault line that runs just beneath the surface. Sometimes a fault appears suddenly, cutting through a field or a street, leaving behind a visible line where the ground no longer matches up. But many faults remain hidden. They are buried under soil, beneath cities, inside mountains. We only know they are there because of the earthquakes they cause or the subtle changes in elevation they leave behind. Scientists use maps, satellite images, and instruments to find them, but even with all this technology, new faults are still being discovered. Sometimes an earthquake reveals one that no one had ever noticed. Other times, careful study of old rocks shows signs of ancient movement, letting us trace a fault's history back thousands or even millions of years. To live near a fault is not unusual. Most of the world's people do. It is part of living on a planet that breathes and changes. Faults are reminders that the Earth is not a static ball of rock. It is alive with motion and full of quiet boundaries. They may seem dangerous, but they are also beautiful in their own strange way. Carved by time, shaped by pressure, and connected to the deep rhythms of a planet always in motion. In their quiet, folded lines, they carry the memory of every shift the Earth has ever made. If you were to look at a map of the Pacific Ocean, you might notice something strange. Around its edges lies a ring, not drawn in ink, but marked by nature. It is a zone of volcanoes, deep ocean trenches, and frequent earthquakes. This area is known as the Ring of Fire. Despite the dramatic name, it does not glow or burn. It circles the Pacific like a quiet boundary, a chain of restless places that sit where tectonic plates meet and shift. From the coast of South America, up through North America, across to Asia, and down to New Zealand, this ring stretches across thousands of kilometers, forming a loop of motion and pressure. The Ring of Fire holds more than 75% of the world's active volcanoes. It is also home to many of the most powerful earthquakes in recorded history. The reason for this activity is found in the structure of the Earth beneath it. Many of the plates that form the Earth's crust come together at this boundary. They collide, slide, and sink beneath one another in a process called subduction. When one plate dives beneath another, it causes pressure to build deep in the Earth. Sometimes that pressure is released as a quake, Sometimes it melts rock into magma, which rises to the surface in the form of a volcano. And sometimes it waits, storing energy that will be released in the distant future. Despite the danger it presents, the Ring of Fire is not always a place of destruction. It is also a place of creation. The same forces that cause earthquakes and volcanic eruptions also build mountains and form new land. Islands rise from the sea. Mountain ranges stretch toward the sky. Over time, landscapes are reshaped again and again. The earth in these places does not sit still. It shifts and breathes in cycles far older than any city or nation built upon it. People have lived along the Ring of Fire for thousands of years. They build homes, grow crops, raise families, and carry on their lives with the quiet understanding that the ground beneath them is never truly still. Some build earthquake-resistant structures. Others learn to watch the signs of volcanic activity. In many cultures, myths and legends speak of fire gods, mountain spirits, and earth giants. These stories are more than fiction. They are echoes of memory, passed down from those who once watched the land rise and shake. At night, if you stood on the edge of one of these volcanic slopes, or looked out over a coastline shaped by earthquakes, you might not see anything unusual. The stars would shine just the same. The sea would move with the tide, but beneath that stillness, the earth would be whispering. It would be shifting, ever so slightly, continuing the slow, quiet dance that has shaped this ring for millions of years. The Ring of Fire does not roar all the time. More often, it simply hums, like a sleeping creature dreaming deep beneath the crust. Every now and then, something unusual is reported in the moments before an earthquake. A strange flash in the sky, a soft glow near the horizon, bursts of light that seem to come from nowhere and vanish just as quickly. These mysterious sights have been described by people around the world, often moments before the ground begins to shake. Some call them earthquake lights, others treat them as myth, but the stories continue. Gentle flickers in the sky that seem tied to something deep beneath the ground. Earthquake lights are not fully understood. They do not appear during every quake, and when they do, they take many forms. Some look like lightning that does not belong to any storm. Others appear more like glowing orbs, hovering above the ground. There are accounts of streaks across the sky, flashes near hillsides, and faint flickers along cracks in the earth. These lights have been seen over cities and farmlands, deserts and coastlines. Some glow blue or white, others shift to green or red. Each sighting brings more questions than answers. Scientists have explored many ideas about what might cause them. One theory suggests that stress in the rocks below the surface can cause electrical charges to form. As the rocks are squeezed and fractured before an earthquake, these charges might rise to the surface and interact with the air, creating light. Another idea is that the movement of the plates disturbs natural gases underground, releasing energy that glows as it escapes. There are also suggestions that piezoelectric minerals like quartz might create light when compressed, much like a spark made by striking two stones together. Still, these explanations remain uncertain. Earthquake lights are rare, and they often vanish too quickly to study in real time. There are photographs and videos, but even those raise debates. Some say they are reflections, tricks of the eye, or unrelated electrical flashes. Others point to their timing and consistency as signs of something more. Whatever the truth may be, the mystery only adds to their quiet charm. Beyond science, these lights carry a sense of wonder. They feel like signals from the Earth itself, brief moments where the planet seems to speak in color instead of sound. For those who have seen them, the lights often come with a feeling of stillness, as if the world pauses to catch its breath before shifting. There is no sound, just the faint glow, a soft warning wrapped in silence. And then, as the light fades, the shaking begins. Even if they turn out to be rare side effects of pressure and rock, earthquake lights remind us that the Earth is not just a place of stone and soil. It is also a place of quiet surprises. A world that sometimes offers beauty in the middle of fear, a flicker of light before the rumble, a silent moment of color before the movement returns. In a way, they are like dreams rising to the surface, glowing briefly, then sinking back into the deep. Long before the ground begins to shake, before any instruments detect a tremor or lights flicker in the sky, something curious often happens. Animals begin to stir. Birds take flight from tree branches in the middle of the night. Dogs bark without cause. Cats dart under furniture. Horses pace their stalls with wide, uncertain eyes. It has been observed again and again across the world. Moments or even hours before an earthquake, animals act strangely, as if they sense something the rest of us cannot. This behavior has been part of human memory for centuries. Ancient writings from China, Greece, and Rome mention animals behaving oddly before quakes. In one account, snakes emerged from their burrows during winter, only to freeze in the cold, escaping from something they could feel but not see. In modern times, farmers have spoken of chickens falling silent before the ground moves. Zoo workers have watched animals pace and tremble in the quiet hours before a seismic event. These observations are not always consistent, but they appear often enough to be more than chance. Scientists have tried to understand what animals might be sensing. One idea is that they detect the earliest seismic waves, the P waves, which are often too subtle for humans to notice. Animals with more sensitive hearing or balance might pick up these soft vibrations and respond with alarm. Another idea is that changes in the Earth's magnetic field or underground gas levels could serve as a warning sign, sensed by animals who rely more deeply on smell, touch, or instinct than people do. There is also the possibility that animals notice shifts in air pressure or ground movement so small they register only through paws, claws, or hooves. A dog lying on a wooden floor might feel a soft vibration long before we do. A bird perched in a still tree might notice the sway of branches that seem unmoved to the human eye. Their bodies are tuned differently than ours, more in rhythm with the immediate world. Despite these ideas, predicting earthquakes through animal behavior remains uncertain. Not every quake is preceded by odd animal activity, and not every strange action leads to a quake. It is difficult to study such things in a controlled way, but the stories continue, passed between neighbors and families, shared across time and place. A cat hiding under a bed, a dog whining without reason, a forest growing suddenly quiet. Whether these reactions come from instinct, pressure, or something more mysterious, they remind us that the world is full of signals we may not always understand. Animals live closer to the natural rhythms of the earth. They do not carry phones or check the news, but they notice the shift in the wind, the soft thrum of distant motion, the quiet before a change. In their stillness, in their unease, we see a part of the earth that listens more closely. And in those strange moments before the quake arrives, they may be hearing what the planet is trying to say. Try to imagine what it might feel like to be the Earth. Not a part of it, not someone standing on its surface, but the planet itself, vast and layered, ancient and quietly alive. Your skin would be the crust, cool and cracked in places, shifting slowly over time. Beneath that skin would be a body of slow-moving stone, warm and heavy, turning gently from the inside out. Your breath would be the movement of continents. Your thoughts might stretch across millennia. And every now and then, you might feel a need to shift your weight, to stretch, to let go of something held for too long. Earthquakes, in that way, are like the planet shifting in its sleep. They are not anger or punishment. They are not loud declarations. They are natural movements, quiet corrections to deep and ancient patterns. The earth is not perfectly smooth, nor is it frozen. It is, always becoming, always adjusting the pieces of itself that no longer sit quite right. When faults slip, when pressure is released, it is the crust settling into a slightly better fit. Not perfect, just a little closer to balance. If you were the earth, you would not feel urgency. Your sense of time would be long and slow. A second would mean nothing. A century might feel like a blink. The build-up of tension between tectonic plates would feel like a gentle tightening, an awareness that something was off. And when the movement came, it would be swift. A deep breath out after holding it in for far too long. You would feel the energy ripple outward, a shudder not of pain, but of release. From the outside, this movement can seem violent or frightening, but from within, it is calm. The earth is not breaking, it is continuing. It is adjusting to the pressures of gravity and heat, of motion and time. Every quake is part of a larger story, one that has been unfolding for billions of years. And though the shaking may last only seconds, the cause has been growing quietly, patiently, in the deep. The earth does not fear its own movement, it remembers each one. The scars of old earthquakes remain, hidden in the folds of rock, in the shape of a mountain, in the curve of a valley. These marks are not signs of destruction, they are reminders of how the planet adapts, how it stays alive. No two earthquakes are the same, just as no two dreams are identical. Some are long and strong, others are short and soft, but each one is an expression of the same need, to shift, to change, to find a new shape. So if the earth could speak, it might say that these movements are nothing to fear. They are not interruptions, they are part of the rhythm, a lullaby hummed in stone. A breath drawn deep beneath our feet, a reminder that we live not on a lifeless rock, but on something that moves and feels and remembers. Far below our feet, tectonic plates are drifting, not quickly, not with any sense of rush, but slowly and patiently. These massive slabs of the Earth's crust move only a few centimeters each year. It is such a small distance that we rarely notice it in a single lifetime. And yet, it is the same speed your fingernails grow, a quiet, steady pace that adds up over time, until mountains rise, valleys open, and entire continents wander across the face of the Earth. This movement is called continental drift. It is a process that has shaped the world we know. Long ago, the continents we see today were not scattered as they are now. They were joined together in one massive landform known as Pangaea. Over millions of years, the plates carrying these continents began to move apart. Oceans opened between them, mountain ranges formed at their edges, and islands began to appear like crumbs from a shifting meal. It can be difficult to imagine something as large as a continent floating. But the Earth's crust is not fixed in place. It sits on top of the mantle, which moves slowly, stirred by heat rising from the planet's core. As this heat rises, it causes the softer rock below to flow. That flow pushes the plates along, guiding them in different directions. Sometimes they slide past each other, sometimes they pull apart, and sometimes they crash together, crumpling like soft cloth and forming tall ranges of rock. Because this movement is so slow, it gives the illusion of stillness. You can build a city, live a life, and never feel it, but look back over millions of years and the changes become clear. Fossils of ancient animals found on distant continents match because those lands were once joined. Rocks with the same age and mineral makeup now rest thousands of kilometers apart. Even the shapes of the continents seem to hint at their past connections, like puzzle pieces that almost fit together. This slow drift is not just a relic of the past, it continues today. Africa is slowly moving northward toward Europe. The Atlantic Ocean is widening. The Pacific Plate is sliding beneath its neighbors. These movements affect earthquakes, volcanoes, and the rise and fall of coastlines. They are the hidden gears of the planet, always turning, always shaping the land we live on. To live on a drifting continent is to live on a journey, one that began long before us and will continue long after. The land beneath us is not a stage, fixed and unmoving. It is a raft floating across a sea of slow, warm stone. And though we cannot feel it from one day to the next, the journey never stops. Each step we take, each road we build, each seed we plant, rests on a surface that is not standing still, but gently moving through the deep rhythm of the earth. Earthquakes are not unique to Earth. Other planets and moons feel their own kinds of shaking. These are called quakes too, though each world has its own version. On the Moon, they are known as moonquakes. On Mars, they are Marsquakes. And although they are not quite the same as what we feel here, they tell us that movement is a part of many worlds, even those that seem silent from a distance. Moonquakes were first discovered during the Apollo missions. Instruments left on the Moon by astronauts recorded subtle tremors that happened months after they returned home. Some of these were caused by meteorite impacts or the sudden cracking of rock as the Moon cooled and shrank. Others happened when the Moon passed closest to the Earth in its orbit, stirred gently by the pull of gravity. These moonquakes could last for hours, ringing through the dry crust of the Moon like the slow chime of a distant bell. Even though the Moon has no plate tectonics like Earth, its inner changes and outer forces can still create motion. Mars, too, has its own story of shaking. In recent years, a small lander called InSight arrived on the surface of the red planet. It carried with it a seismometer designed to listen closely to the ground. Not long after it settled in, it began to detect Marsquakes. These were not strong or violent, but they were clear. The surface of Mars was not as quiet as it once seemed. Some of the quakes came from deep inside the planet, as old volcanic zones cooled and cracked. Others may have been caused by small meteorite strikes or shifts in the crust. The data helped scientists learn more about the layers hidden below the dust and rock. It gave them a new way to understand the heart of a planet far from home. Even some moons of Jupiter and Saturn are believed to shake. Europa, a frozen moon wrapped in a thick shell of ice, may have tremors as the ice stretches and breaks from tidal forces. Beneath that icy surface, scientists believe there is a liquid ocean, a place where shaking ice could stir the waters below. On Enceladus, another icy moon, geysers of water shoot from the surface. This too could be tied to quakes beneath the crust, soft whispers of movement from deep within. These distant quakes remind us that motion is not only an earthly thing. Across the solar system, in the cold silence of space, other worlds breathe and shift. Their movements may be slower, their surfaces quieter, but they are not lifeless. They too feel the strain of gravity, the pressure of time, the stretch and settling of layers, earthquakes, moonquakes, Marsquakes, and more. Each one is a small reminder that the universe is not frozen. It is always changing, always in motion, even when no one stands to feel it. One of the great questions people ask about earthquakes is whether we will ever be able to predict them. Will there come a day when we can say with certainty that the ground will shake tomorrow or next week or next year? For now, the answer is no. Despite all our instruments and maps, all our models and measurements, earthquakes continue to surprise us. The Earth keeps its secrets well. It moves when it is ready, not when we expect. Scientists can estimate where earthquakes are more likely to happen. They know which faults are active. They can see how fast tectonic plates are moving and where pressure is building. In some places, they can say with confidence that a large quake will happen again, but they cannot say exactly when. The Earth gives very few clear warnings. Pressure builds slowly and silently. A fault may hold tight for decades or even centuries before slipping. It may release its tension in a single large quake or in a series of smaller ones. There is no fixed pattern. There have been moments of hope. Sometimes small changes are noticed before a quake. Groundwater levels may shift. Gases might seep from deep underground. Animals might behave strangely. And yet, these signs are not reliable. They happen without earthquakes just as often as they happen before them. A light flicker in the sky or a burst of gas from the soil is not enough to sound an alarm. Many people would rather not be warned at all than be warned falsely. Still, research continues. Scientists are studying slow slip events, which are movements along faults that happen over days or weeks. These may not cause shaking, but they might reveal when a fault is waking up. Instruments grow more sensitive. Satellites track the smallest changes in the shape of the ground. Networks of seismometers listen for tiny tremors that could mark the beginning of something larger. One day, these efforts may bring us closer to knowing more, but the Earth does not give up its patterns easily. Even if prediction remains out of reach, preparation is not. Engineers have learned how to build stronger buildings that can bend without breaking. Cities have developed warning systems that detect the first waves of a quake and give people seconds to take cover. These systems are not perfect, but they save lives. And while we cannot predict the moment, we can understand the risk. We can map the danger zones, plan for safety, and teach people how to respond. There is a kind of peace in accepting what we cannot control. The Earth moves on a schedule, far older and slower than ours. It shifts when it must, following rules we are only beginning to understand. And though we may never know exactly when the next quake will come, we do know this. It will come quietly at first, deep in the crust. It will travel upward like a message written in stone, and once again, the Earth will remind us that it does not ask for permission to move. It simply moves. Though we cannot stop earthquakes from happening, we have found ways to live with them. Over time, people have learned to study the ground beneath their feet, to build with care, and to prepare for the moment when the stillness gives way to motion. It is not about avoiding the Earth's restlessness. It is about moving with it, understanding that our homes and cities must bend instead of break. This is the quiet art of earthquake safety. In places where earthquakes are common, buildings are designed differently. They are made not to resist every shake, but to sway gently with the ground. Tall buildings in particular are built to flex, like reeds in the wind, allowing the energy of a quake to pass through without tearing them apart. Special materials are used to absorb shock, and foundations are made to settle evenly when the ground shifts. Engineers study past earthquakes to learn how structures failed and how they can be improved. Every lesson is a step toward greater safety. Some buildings are placed on base isolators which act like cushions between the structure and the ground. These allow the ground to move underneath without transferring all that energy upward. It is a simple idea that makes a great difference. Even in smaller homes, thoughtful design can help. Roofs are secured tightly, walls are braced, heavy objects are fastened to prevent them from falling. The aim is not to stop the Earth, but to avoid harm when it moves. Cities also prepare in larger ways. Emergency services practice how to respond. Schools and offices hold drills so people know what to do. Roads and bridges are built with joints that allow them to stretch slightly. Water pipes and power lines are made to shift without snapping. All of this happens quietly in the background of daily life. It is not always seen, but it matters deeply when the shaking comes. In some regions, early warning systems have been developed. When a quake begins, sensors detect the first waves and send out alerts. These systems may give only a few seconds of warning, but that is often enough to take cover, stop a train, or pause a surgery. Those seconds are precious. They are the difference between surprise and readiness. Preparedness also includes knowledge. People are taught how to drop to the ground, cover their heads, and hold on until the shaking stops. They learn to keep supplies on hand and to check their homes for hazards. Communities share information, and families make plans. In this way, safety becomes part of daily life. Not a fear, but a quiet respect for the earth and its ways. To live with earthquakes is to accept a world that moves. It is to know that the ground is not fixed, and that change can come at any time. But it is also to know that we are not helpless. We have learned to listen, to build wisely, and to stand again after the earth has spoken. At first, it might seem strange that something as unsettling as an earthquake could have any purpose at all. They feel sudden, wild, and sometimes destructive. But when we look more closely at how the earth works, we begin to see that earthquakes are not just random events. They are part of something larger, something necessary. They are the result of a planet that is always moving, always adjusting, always changing shape in response to deep forces we rarely see. Without earthquakes, the world would be still in a way that is not natural for Earth. Tectonic plates do not slide across the planet peacefully. They resist and catch and strain, like muscles tense too long. And when that strain becomes too great, the energy must go somewhere. Earthquakes are the release. They are the moment when the Earth says enough. Without that release, the pressure would continue to build, creating even greater instability. In a way, the Earth is protecting itself. It moves in small ways now to prevent larger problems later. It finds balance by letting go. More than that, earthquakes are part of the cycle that shapes the land. They help form mountains and valleys. They open faults that bring up minerals and water from deep within the earth. They move the crust, pushing continents into new positions over millions of years. Without earthquakes, the continents would not drift. Oceans would not open or close. The face of the planet would remain frozen in place. Earthquakes are part of what makes our world dynamic. They are not just side effects of motion. They are part of the motion itself. Volcanoes, too, often share a connection with earthquakes. When faults shift, they can create paths for magma to rise. When pressure changes underground, it can lead to eruptions that build new land. Many of the islands we know today, from the Pacific to the Atlantic, were born from the marriage of earthquakes and volcanic fire. Even now, new land is forming beneath the sea, pushed upward by the same forces that shake the ground above. There is beauty in that. A kind of quiet wonder in knowing that something so sudden and powerful is also creative. The earth is not always gentle, but it is always purposeful. It changes itself not out of anger, but out of need. Each quake is a chapter in its long story, a sentence written in motion, a breath taken after holding still for too long. So when we ask why the earth must shake, the answer is simple. It must shake because it is alive, because movement is part of its nature, because silence, if it lasted forever, would mean something had stopped working deep below. Earthquakes are not flaws. They are functions. They remind us that beneath the ground, the world is not cold or lifeless, but filled with energy, warmth, and quiet intention. They are not punishments. They are processes. They are part of the way this planet stays in balance, even while we sleep above it. When an earthquake ends, the silence feels different. It is not the same stillness that came before. It is a kind of quiet that follows motion, a pause after the earth has let something go. The ground settles, the shaking fades, the air, once filled with invisible waves, now feels calm again. People step out from doorways, from beneath tables, from wherever they took shelter. They look around, they listen. Even the birds seem unsure for a moment. Everything holds its breath, as if waiting to see if the movement will return. Sometimes, aftershocks follow. Smaller tremors that ripple through the crust as the planet adjusts to its new shape. But eventually, even those grow faint. The energy has been spent, the fault has slipped. The earth has sighed and stretched and found a momentary balance once more. What comes after is not just stillness, it is recovery. It is the beginning of rebuilding, of remembering, of understanding. In the days that follow, cracks may be repaired, walls painted, roads mended. People talk about what they felt, how long it lasted, what it sounded like. They compare stories. They share a memory that now belongs to everyone who was there. Even children carry the feeling with them, tucked away like a dream they cannot quite explain. The earth moved, and they moved with it. But long after the cleanup is done, the earthquake remains. Not in damage or fear, but in awareness. A deeper knowing that the ground beneath our feet is not a fixed stage, but a living part of the world. Every rock and hill, every sidewalk and forest rests on something that breathes. It is easy to forget this when everything feels steady. But the memory returns with each soft tremble, each aftershock, each quiet moment when we look at the land and remember that it too has its own rhythms. And so the earth continues. It moves in slow waves we cannot see, storing energy, shifting gently, waiting. The next earthquake may come in years or centuries, or it may come tomorrow. We do not know. But we have learned to live with this uncertainty. We have learned to build, to prepare, to understand. We have learned that safety does not mean stillness. It means listening, watching, respecting the motion that lies just below the surface. In the end, when the shaking stops and the world feels calm again, there is something comforting in knowing the earth has not stopped being what it is. It is not broken. It is simply doing what it has always done. Moving, breathing, changing. And we, the ones who live upon it, have the chance to move with it, to stand again, to build again, to dream again. Even after the tremors fade, the story continues, written in stone and soil, carried in memory, echoed in the soft silence that follows, a silence that is never truly empty, just resting, just waiting, just being still for now. So, as you drift off now, letting your breathing slow to match the rhythm of the quiet world around you, remember that even the strongest tremors begin with stillness, and that beneath every calm moment, the earth is always gently turning, stretching, settling. Earthquakes may seem sudden, but they are simply the planet's soft way of staying alive. Thank you for wandering through this sleepy science story with me. If you'd like more gentle journeys like this, a like on this video and a whisper of a subscribe would mean the world. And if you haven't already, tell me in the comments where you're tuning in from. I always love imagining this circle of sleepy minds, connected like tectonic plates in the dark. Until next time, sleep well, and may your dreams be full of soft soil, patient stones, and the silent strength of the earth.